One more parent function that I want to talk about separately is f of x is equal to sine x. And the reason why I want to do it separately is because describing some of the characteristics is very tricky with it. This video is going to be very tough to explain, and it might be very tough for you to understand. But even if you don't fully understand it, it's honestly not a big part of this chapter or a big part of the course, so don't even worry about it. But anyways, let's go through some characteristics for sine x. So here's the graph. If you remember, this is how sine x looks like. So let's start off with the domain. What is the domain of sine x? Well, notice there's no restrictions on the x. They can be any value. So x is an element of real numbers is the domain. What about the range? What values can the y take? Well, the y can be anything as long as it's between -1 and 1. Right? The wave alternates between -1 and 1. So y is an element of real numbers, but y has to be between -1 and +1. Now, for sine x, where are there x-intercepts? And this is where it starts to get a little tricky. So try to pay careful attention. So notice how there's x-intercepts at -360, right? It goes through the x-axis there, -180, 0, 180, 360, and so on and so on. So notice how there's like this space of 180 between all of the x-intercepts. So let's write all of them out. So we'd have -360, -180, 0, 180, 360, and it keeps going on forever to the positive side and goes on forever to the negative side. So notice how all of these are multiples of 180. So I can like factor out a 180 from each of these, and I'd have -1, 180, sorry, this would be -2. Right? -2 times 180 is -360. -1 times 180 gives us a -180. 180 times 0 gives us 0. 180 times 1 gives us 180, and then 180 times 2 gives us 360, and so forth and so forth. So we can describe this pattern in general as 180 times m, where m is an element of z. And what this element of z means is all positive and negative integers inclusive of 0. So we can take 180 and multiply it by any positive or negative integer or 0, and we would get all of the x-intercepts. So that's how you would describe the x-intercepts in general. A little tricky with this element of z and how we got from here to here. But again, if you're a little confused, not too important, but yeah, that's how you would do it. There are a couple of intervals of increase in this specific sine x that we drew here. So notice from -450, an x value of -450 to -270, the y values are increasing when we read from left to right. So from -450 to -270, that's an interval of increase. Let's find another one. Well, notice from -90 to +90, the function is increasing there as well. So from -90 to +90, that's another. And then from 270 to 450, that's another interval of increase. The y values are going up when reading from left to right. And this pattern continues on and on forever, both ways. So we have to find a general pattern. We have to conclude this generally. So notice how all of these numbers, they're all multiples of 90. So we could take out a 90 from -450, we would end up with -5. 90 from -270, we would end up with -3. So I took this, rewrote it like that, factored out 90 from each term. We could factor out 90 from all of these, so we'd have -1, 90, we're left with 1. And then here, 90, this ends up with 3 when we factor out 90 from 450. we're left with 5. And now it's sort of easier to see a pattern. Notice how each of these numbers, -5, -1, 3, the difference between them is 4. Same thing here, this -3, 1, and 5. The difference between them is 4. So we can tell that the next pattern would be 7, 3 plus 4, and the end of the interval would be 90, 5 plus 4 is 9. So if we took this and rewrote it, we would have 90 times 7 is 630, and then 90 times 9 is 810. So that would be, if we extended this graph all the way, that would be another interval of increase from an x value of 630 to an x value of 810. And so on and so on. So we could continue with this pattern. So to sum this up generally, what we can do is we can take 90, take one of these points, let's take the 3 and the 5, and notice how we're always adding or subtracting a multiple of 4 for it, and then for the end of the intervals, we'd start at 5, and we're subtracting or adding a multiple of 4, so m can be an element of z, where z is any positive and negative integer inclusive of 0. And this general pattern here would work, so we can test it out. For example, if m is 0, if we plugged in 0 for m here and 0 for m here, we would have 90 times 3 and then 90 times 5. If we plugged in -1 for m, 4 times -1 is -1, 3 minus 4 is -1, so 90 times -1, and here if we had -1 for m, this bracket would be +1, so we'd have -1 and +1. If we plugged in -2, we'd end up with -5 and -3, and so on and so on. So this pattern here works. Just getting to it is a little tricky. If you didn't get that, rewind the video, watch it again. I'm sure you'll get it the second time. Again, if you're not too comfortable getting it even after watching it multiple times, don't worry about it too much because it's not a major part of this course. But yeah, these intervals of increase, you have to be able to find where they are on trig functions and then make a general statement for them, because they're going to continue on forever. Same thing with intervals of decrease, which we'll do in a sec, and these x-intercepts. Now moving on to intervals of decrease, I erased the intervals of increase part just to give myself more room, but we're going to follow the same process that we followed there. And I already wrote out some of these intervals for you. So notice how from -270 to -90, the y values are getting smaller. So there is a interval of decrease there. From 90 to 270, that's another interval of decrease. And if we were to extend the graph out further out, it'd be another interval of decrease from 450 to 630. And this pattern keeps going on and on forever to both the negative side and the positive side. So notice again how each of these is a multiple of 90. So taking out 90 from -270, we're left with -3. Taking out 90 from -90, we're left with -1. Here, taking out 90, we got 1, and then 90, we got 3. And then here we got 95, right? 450 divided by 90 is 5, and then taking out a 90 from here, we're left with 7. So I just basically factored out a 90 from all of these numbers here. And now we can see the pattern. -3, 1, 5, all of these are increasing by 4 and decreasing by 4. And then these as well. From -1 to 3 to 7, these are increasing by and decreasing by 4 as well. So to make a general formula for the intervals of decrease, let's pick one of these. So let's pick these two here. So we'd have 1 plus 4m, and here we'd have 93 plus a difference of 4m for all of the other ones, where m is an element of z, meaning that it can be all positive and negative integers. And we can test it. So if m is 0, right, this bracket would be 1, this bracket would be 3, and we would have 1 and 3. 90 times 1, 90 times 3. if we try an m value of 1, this bracket would be 5, this bracket would be 7, 5 and 7. If we try -1, we would get -3 here, and -1, if we put it in for m, we would get -1, -3 and -1. So the pattern works forever for all m values as long as they are positive and negative integers inclusive of 0. And to finish off the video, let's talk about these 3 characteristics for Sine X. So continuity. Notice if I run a pencil through the function, I never have to take it off the paper all the way to positive infinity, all the way to negative infinity. So Sine X is continuous for all x values, for the whole domain. Symmetry. We establish in the example video of symmetry that Sine X is odd because it's rotationally symmetrical about the origin. If we take this portion of the graph and rotate it around the origin, we would get this portion. Now, end behavior. What happens as x goes to positive infinity and x goes to negative infinity? What's happening with the y values? Well, the y values, we say it's an oscillating function. This word just means that the y values are, as you go to an infinite x value, the y values are just alternating between a certain range. In this case, the range is between -1 and 1. So this word oscillating is all you would put for the end behavior of Sine X.